Hey, we're recording. All right. Chapter 4, understanding and comparing distribution. So in the last chapter, we looked at information, and I carefully didn't use the word distribution, but it might have slipped out from time to time. But almost always more interesting to compare the groups. So we got to compare groups of information or data. You could use histograms, and then you note the shapes, the centers, the spreads of the two different distributions. And when you look at this, what do they tell you? And let's unpack this. This is the average wind speed during the winter and during the summer. And right off the bat, yes?
So is the summer, like the numbers on the, is that like each year? Or is that?
So this is just the number of days. So I'm not sure. Yeah, so it's not exactly clear, right? This is the number of days.
I think that's average wind speed.
Yeah, this is the average wind speed. So yeah, so it's a little ambiguous about what they're but this is the average wind speed in miles per hour. So what they're saying is 0 miles per hour in the summertime. That happened almost 80 days.
Oh, I see.
In the summertime, an average wind speed of 3.5 to 4 was, maybe 1 day. But then when you look at the winter, average wind speed of average wind speed of say 1 miles per hour or close, 0.5 to 1, that happened 20 days. Average wind speed from 1 to 1.5, 20 days. 1.5 to 2, a little bit more than 20. And so across the board here, what I gathered is it was more often kind of a little bit more wind, and there was a little bit more of a spread, a little more variation in the winter. Lower number of days, but in the summertime, it seems like most of the days of summer, you had very little wind. Does that make sense to you guys? So that's what we got to look at. So now, box plots offer an ideal balance of information and simplicity, hiding the details while displaying overall summary information. We often plot them along side by side for groups or categories that we wish to compare. And so now this is a different arrangement. It says the average wind speed, so they change the axis, and then this is the month. So the wind speed here in miles per hour, in January, you could see that the spread kind of went from 1 to 3, but we have some extreme values, 0 degrees here, maybe 4.5 here. February, the spread was from 3 to 1. That's the interquartile range. We have this one outlier where it was 7 miles per hour, roughly. So who knows? Maybe there was like a windstorm one day. And then, no, it doesn't tell us the days. It just tells us the data, right? The spread in the center. March, a little more. Now, if you look here, June, July, August, there's not a lot of wind in the summertime, but then as it starts to get colder, you see the wind speed pick up. Also notice in November, you have a very wide spread. So there's a lot of information you could get by this display. So what about the outliers? Are there any clear outliers that are reporting the mean and standard deviation? Oh wait, I read that wrong. It says if there are any clear outliers and you are reporting the mean and standard deviation, report them with the outliers present and with the outliers removed. The differences might be quite revealing. The median and IQR are not likely to be affected by outliers. So what they're saying is, you see how you got this little thing here, this thing here? These are the outliers. Okay, these little dots are the outliers. And what they're saying, if you're going to do the mean and standard deviation, you could toss them out, but you need to report that they were there. Okay. So now this is the raw data and the day of the year and the different wind speeds for those days. Now this is what you would call as a time plot of the data. That one, you can kind of see that the average wind speed is lower for sure. So these are just the wind speeds that they record at different times of the day on each day. But there's a pattern there, but you could see in the first two displays of the information, it was a little clearer to get some insight as to what was going on. So our relationship entered its decline at this point. Then that's when you started graphing everything. Coincidence. That's kind of a joke. So if you look at the skewed data, because that's really what you have is the skewed data. So now in this particular case, this is a different data set. But I like what they've done here is they've created a box plot, right? Remember, this is the first quartile range. This is the median. This is the third quartile range. Then they have the two fences, but then you notice they have what they consider to be outliers. But this is the raw data, okay? It looks like it's the number of CEOs and how much they get paid. So there are some CEOs that are making some bank, but most CEOs of companies are in this range, okay? And these are in millions. So most CEOs might get 1, 2 million, 3 million, 4 million, 5 million, 6 million. There's 12.5 million, but there's this one guy. He's probably making, looks like 145 million or something like that. That's pretty good. So when the data's skewed, it can be hard to summarize and figure out what the center of the spread is. It's hard to decide what the most extreme values are. And the values of the outliers are just part of the stretch of the tail. So you got this big long tail, right? And remember, we would say that this is right skewed because the tail is on the right side. Well, is there anything useful about this data? Well, yeah, of course there is. You could take that and you can re-express that information to improve the symmetry. One way to make skewed data more symmetric is to re-express it or transform the data by applying a simple function such as a log function. So if you take a log function and input the raw data, what happens is it tends to make it a little more symmetrical. So it makes it a little easier for you to see the center. Now this is a very common thing to do in science if they want to, and they'll do this with even symmetrical data. But it helps you a little bit better to see what the center is. So if I were to say to you, you're a CEO of a company, what do you expect to make? Well, looking at the log data, you would say anywhere from 6 to 7 million. I mean, it's pretty clear in this particular case, right? Note that the change in skewness of the raw data, the previous slide, this one, now looks a little different than this one. Now, it's not easy to see, but I mean, you can see that the majority of this chunk right here is between 6 and 7, but how do you know? This way, it's really clear. Okay, it's really clear. So, what can go wrong? Well, sometimes you could do things and it makes things look worse or better, and sometimes it's misleading. So look at this. Article or this cover right here. What's it talking about? Yeah, they're talking about their tuition, and you got to zoom in really close. But here is a plot of their tuition, how much they're charging students, and their ranking. But do we know how much that is? We don't know how much that is. So they may have taken a dip percentage-wise, but we don't. How do you compare that? And you're comparing two different things, right? How much of an increase? Maybe it went from $20,000 to $21,000. Or maybe the ranking went from 12th in the nation to 15th. And what is the ranking based on? Is it an overall ranking? Maybe because there was an increase in the tuition. Maybe that's a factor. Maybe this is like, depending on the report might be what's the best school for, what school gives you the most bang for your buck. By the way, my lab partner graduated from Cornell with his degree in physics. Yeah, good for him. Shout out to Cornell. What can go wrong? Well, the outliers can definitely skew the data for sure. So if I were to take the average here for a smoker, these outliers are going to mess up my centers, okay? So we got to be careful of when we compare groups that have different spreads. Consider these side-by-side box plots of, and I don't even know what that word is. Is it coatine? Cotatine? I don't know what that is. It's probably some derivation of nicotine. But anyways, no smokers barely have any. I'm not sure what ETS is. Probably secondhand smoke or something. And then an actual smoker. So they clearly they have a higher level of it. And so we can look at the data, and there's a couple ways we can manipulate the data. So what we learned is that when we compare the data groups and we're looking for patterns among the groups over time, we can look at the raw data. We can look at and consider the outliers. Box plots are pretty effective in some cases. Outliers are an interesting thing. We can do some math with the outliers and we can do it without, but regardless of what you're doing, you have to let people for themselves decide if the outliers are important or not. So you would never toss out an outlier. In other words, if the outlier is so off the chart and you decide I'm not going to include it to find the mean, you still have to do both. You have to do the mean with the outliers and then do the mean without the outliers, and let the individuals who read the data determine if it's okay to toss out that data. Okay. A lot of times in published research, they'll do both. They'll show you the data or the summary of the information with the outliers and without the outliers, and then they'll explain why they think the outliers exist, which is good. And then you can go, oh, well, that makes sense. You just toss it out. Or, depending on the application, you might say, well, I can't just toss that out, because that's a real thing. A lot of times this stuff is measured over time, and so you can look for trends even with the raw data. So if you looked at the raw data of the wind speeds, you could see that there was a dip, but clearly histograms and box plots helped. When comparing distributions, make sure to compare the center and the shape and the spread, all three required for full credit. So you're going to have a lot of questions like this on the AP exam. When comparing the center and spread, use comparison words like mean. Mean, 34 miles per hour for group A, while the group mean for B was 30 miles per hour. Now they're saying that's not full credit.
Oh, it has to say large.
It has to say large. Group A has a larger mean of 34 miles per hour compared to group B. So these are AP tips. So when you go to answer the questions on the AP exam, make sure you do that. Okay? Are there any questions for Mr. Adams?